Hello guys, welcome back. So today we will be like discussing the answer of a question from JAM to 2025 of this year. These type of questions are sometimes asked, and the easy thing is if these type of questions are asked, you can very easily solve them even in less than 1 minute, and you could get some scores out of that. So you you should know how to solve this question so that if in any exam you are faced with this question, you can quickly solve them and like go ahead for the other questions. So we can see in this question they are asking us to find the number of alpha particles and the number of beta particles in the given decay. So it's decaying from radium to lead. So the first thing we need to do is we need to know what the alpha and beta particles are. So an alpha particle is basically the nucleus of a helium atom. And these, as we know, these things are the mass number and the atomic number. The mass number equals the total number of protons and neutrons present in the nucleus, and the atomic number is just the number of protons present in the nucleus. And for following this convention, for every alpha particle, which is a helium nucleus, as we know, a helium has two neutrons and two protons. So if we take the total number of neutrons and protons, it is 4, which is the atomic number. Atomic numbers are usually denoted by Z and the mass numbers by A. So helium we will have like 4, and here we'll have 2, which is the number of protons. And for a beta particle, which is basically an electron, here we have -1 and here we have 0. So basically what happens in a beta emission is you have a neutron, and the neutron gives away an electron, which is the beta particle, and the neutron itself converts to a proton. So a neutron has mass number of 1 and atomic number of 0, because atomic number is the number of protons. So it is a neutron is not a proton. But when it gives off a beta particle, it converts to a proton. So now it has an it has an atomic number of 1 and a mass number of 1. So the change from here to here is 0, and the change from here to here is +1. So just to keep the balance, the beta particle has to have a -1 here and a 0 here, so that the result of these two is again a neutron, which is 0 and 1. So as you can see, this is an alpha particle and this is a beta particle. So here you can see the mass number changes from 223 to 207. So the first step is obviously to check how many alpha particles have been emitted, because as you see, the beta particle does not change mass number. So this changes mass number by 4. So here change is 223 to 207, which is 16. So it changes by 16, and for each alpha particle it changes by 4. So you have to find how many number of alpha particles are there. So we divide it by 4, so we get 4. So there is 4 alpha particles. Now we have to find the beta particles. As we see, beta particle only changes the atomic number by -1. So here what we can do is we see what should the atomic number be after the loss of these 4 alpha particles. So you see the atomic number is 88 at the beginning, and you had 4 alpha particles, so you had 4 of helium 42. So from 223 it became 4 into 416. Subtract from that, so 207. Let's like name this x. So it's 207, and like 4 into 2 is 8, so it should be 88 minus 8, so it becomes 80. But in the question we see that it is not 80 but it is 82, so it means that 2 neutrons have converted into protons and increased the atomic number by +1 each. So it means there have been two beta particles, so -1 0, and so this becomes 82 and 207, so it becomes lead. So now you have 2 beta particles and 4 alpha particles. So the answer would be A, 4 and 2. So this way you can very quickly solve this type of uh, questions if they ever come in any exam.